Ladies and gentlemen, welcome back to another live stream. Alright, so in this live stream, we're going to be trying to create a video player using Vulkan and possibly also using libplacebo, which is used by MPV or MVP. Yeah, MPV, sorry. MPV video player. And we'll see how it goes. We're going to be doing it in Windows, but this should work hopefully in, or at least we're going to try to make it work on all platforms in general. But yeah, because we're going to be using SDL3 and so on. But anyways, so let's go ahead and let's go. Alright, so obviously later on we're gonna try to make it like zero copy and like hardware accelerated and all that cool stuff, but we're gonna go slowly and go from there. It's not gonna be like when you hear vibe coded, you usually think that there's someone that doesn't know anything about what they're doing and they're just using the AI to do it. I kind of know what I'm doing to some degree, so this is not exactly vibe coded in the traditional sense. And also, I'm gonna be doing the setup myself because I tried to to let the AI do the CMake and like the project setup like yesterday, and it did horribly. You know, it just flopped so badly. And yeah, so I'm gonna be setting up the projects myself first, hopefully, using just Gemini and, you know, my own little brain. And then from there, later on, we're gonna be using open code for the rest, right? So yeah. Okay, so that was just a little background, I guess. And in fact, I could show you like clip placebo FFMPEG. There you go. For example, there is this Reddit post right here from 2 years ago in the FFmpeg kind of like Reddit. I'm not a coder or a dev, but blah, blah, blah. I've been trying for hours to build it and integrate it into FFmpeg, and tutorials and ChatGPT have just sent me in circles. This is exactly what vibe coding does if you don't know what the hell you're doing, especially when it comes to CMake and like infrastructure and like setup in general, essentially. If anyone can tell me through it, because yeah, like the AI could generate a lot of cool code for you, but when it comes to actual setup and finicky stuff like build system, it really sucks. So today we're going to be trying to hopefully do this. We're going to be using built up static libraries essentially. In Linux, it's actually very easy. You just like install FFmpeg and like install libplacebo or whichever the hell you want to install, and then you just say find package and boom, done, which is pretty sick. You might also need the Vulkan SDK, obviously, the Vulkan SDK, and make sure that you have like maintenance tool and make sure to add or remove some components. Make sure you have all these components on, because we're going to be using the SDL of this of the SDK essentially. And yeah, yep. All right, so we'll see how it goes either way. All right, so now we got these libraries. Next, let's see what we could do. So I got div here. I got Kotochaku video player. So that flopped so badly yesterday, so we're gonna remove it. Continue, and then try again. Okay, cool. Now let's just make a new one, new folder. I'm gonna call it Kotochaku video player, and let's see what we could do. Right, so I'm gonna open this in like open with code, and let's see. So Control Shift P, and I do remember there was like a way to actually start up like CMake, if I remember. Search project, open project, add file to CMake list. Yeah, I don't remember where it was. setup project, or what was it? Start. Ah, okay. There's a quick start here. Interestingly, what if I did a quick start? C++ and executable. Boom. Let's go. I just remembered this one. Obviously, I'm using some. Wait a second. What's going on here? Let's see. No CMake CXX could be found. Really? Okay. Let's switch kit. Select a kit. Can I? Okay, hold on. Select a kit. There you go. I'm gonna be using Clang MSVC. Yeah, Clang MS. So basically Clang CL. If you want Clang CL, you gotta make sure to install like Visual Studio installer, and then you just say modify, and then in obviously you can just use. Wait. Sorry. Since we're gonna be using like built-in tools, actually it should work with MSVC libraries too. Yeah, so that's fine. I mean, you could still use just MSVC instead of Clang, but I really prefer Clang. It's way better. But yeah, so you kind of just go here, right, and make sure you have Clang tools for Windows, baked in here, and you should get it. And it also gives you CMake there and everything you're gonna need. Otherwise, here's my extension, just in case if you guys interested. I'm using Kylan instead of like the official Visual Studio Clang D extensions, nor their C++ extensions or CMake tools, because they just suck. You're gonna need like a lot of extra settings to get it to work properly. So instead, I'm just using these from Kylan IDE, it's just extension pack for C, C++. You got Kylan's Clang D, Kylan's CMake workflow, and this guy pretty much. I also got Airlens, and yeah, that's all. That's all I think, pretty much. And as for my settings JSON. You could set the Clang D path to Microsoft Visual Studio Clang D from your Clang LVM MS like Clang tools, but you don't really need to with these kind of extensions. And then you can also set the CMake generator to Ninja. Obviously, you gotta have Ninja on your path. You gotta download it. Just search for C++ Ninja. It's way faster than the Visual Studio generator, essentially. But yeah, there's just a little bit of like background if you're curious. And as you can see here, I got bin and my Ninja here, and it's basically added to environment variables. As you can see, there's just a lot going on to actually set up your path, like your system, set up your projects, etc. That's why like AI really suck at this. You got the path / bin and so on. Anyways, let's continue, I think. So we got here main.cpp. Do you want to install the... No, bro, come on. It really is so annoying. I don't know how to disable that one. Anyway, let me try to actually build this now. Is it using Ninja? I wonder. We'll see. Hello, there you go. And is it using Ninja? What is it using? I can't really tell what it's using though. It definitely uses CMake, but there's no like yeah. So it's better to just make a CMake preset here, pretty much. CMake presets.json. It's way more reliable, essentially. And I gotta figure out how I can bank that, because I could never remember all these crap, just like syntax stuff. A TLDR about CMake presets. I could ask the AI to generate it for me, but it just sucks. All right, so let's see. And or you could actually, there is another way you could do this. Instead of doing it this way, let's just say CMake presets Wait, add, yeah, add configure or add build preset, I think. Yes, let's add the configure preset, and we're going to create it from the compilers. And then we're going to select our Clang CL, which is MSVC CLI here. Boom. And we're going to call this preset default or whatever. And then we're just going to remove this display name here. We're going to remove this description. We're going to switch the generator to Ninja. Instead of Visual Studio, we're going to remove this toolset. We're going to remove this architecture. And we're going to keep the binary directory, cache variables, fine. As for the CMake compiler, remove this and just let it be clangcl instead. It's stupid that it's hard coding the actual path. And once you do this, like Visual Studio Code would understand what you're trying to talk about, and it would just load the Visual Studio vars for you, which is nice. And here we got like default debug, and we don't need any display name or whatever the hell. Configure preset, configuration debug, and boom, done. You could also add, whoops, default release if you want, and then just switch this to release. And yeah, it might be cool to make sure that it always CMake export compile commands too, I think. Is that right? I mean, like the current extensions that I'm using already does that for you, but if someone is using the other ones, then it wouldn't work for them. So, or like NeoVim or whichever. So just better add it anyways. On or like true, or yeah, I think, or yeah, or you could just go with string on, I think. And yeah, is there anything else? Yeah, I don't think so. We're good. We're good. All right, so let me just, I guess, just to make sure, I'm gonna restart my Visual Studio Code here, so I make sure that it's using the CMake preset. And boom, it asks me which preset. I'm gonna go with the default. And let's go. Good luck getting this to work with AI. Like, it's insane. There you go. Okay, cool. Cool. Now, I am not sure what that thing contains. Hold on. Wait. Obviously, we're still gonna vibe code this, but we're gonna do the setup ourselves. Wait, what the hell? What's wrong with you? Oh, I've already like extracted it. Okay, cool. Let's see what's up. So we got some binaries here, so like the DLLs and so on. Nice. We got the doc, the includes. We got the lib, avcodec.lib. All right. We got presets. So we got no CMake config, unfortunately. But wait, is there like a, what is it called? PKG config thing? I remember. There's none of that either, I think. PC, it's like .pc. It's not even required really, but it would be cool if that exists, but I don't think it does. Anyways, let's see how we're gonna do this now. Is there like a tree thing? Yeah, there you go, cool. Okay. Let's just ask the AI about this part. I don't remember exactly how it works. How to link pre-built libraries in modern CMake, like FFmpeg. Is that GAN? Yeah. All right. Is the live stream working? Let's see. All right, it seems to be working. Cool. All right, so we got external and then the FFmpeg. All right, cool. So let's make an external folder here, sure. And let's bring out the FFmpeg folder stuff here. So FFmpeg, and we're gonna reveal in File Explorer, and we're gonna bring in the pre-built libraries. Otherwise, you gotta build them yourself, which takes years. And you're gonna find a way to get a make working on Windows. I actually did get make working on Windows before. But either way, it takes a long time, really. But like you had to go through a lot of hoops to get it to work without adding all sorts of crazy DLLs and so on. And I'm still not sure if it would actually work either way. Or you could use MSYS, but that wouldn't work like natively on Windows, I think. Either way, just a lot of trouble. So let's just go with this for now. So we're gonna basically just copy everything here into this FFmpeg external directory thing. And you're good to go. Cool. All right, so yeah, cool. Now let's see what we're gonna do. So the first thing, you gotta define the base path to the Gyan pre-built directory, which is cmake current source external FFmpeg cache path, and list the FFmpeg components you need. Cool. And create modern cmake imported targets dynamically. So for each library we have, we're gonna add a new library called FFmpeg. In known imported, detect the library file names based on the toolchain. Okay, sick. Lovely. So it would work on any kind of platform, essentially. That's nice. And then set the target properties, interface include, imported location. Yeah, that looking cool. So let's just grab that. That looks perfect. Since I told it modern CMake, so it kind of did a good job there actually this time. Okay. Cool. Now what we could do is we could target link libraries. And let's go. And let's just do this. And let's actually do this. And I think that should do the trick, right? Kodachaco video player, private. And let's see if that works. Okay, looking good. Now, how about we come here and now do we have access to FFmpeg stuff? What's the headers are called? I forgot. Oh yeah, AV, sorry. AV codec, right? Or something? Yeah, I don't remember what the FFmpeg header is called. And we should add extern C because we're in C++ pretty much. And yeah, oh, I almost forgot too. We should, yeah, always forgot. So you gotta make sure to tell CMake to also copy those libraries, those DLLs from the bin directory to the actual application directory. Obviously, you gotta use this. And yeah, that should work in terms of the CMake part, I guess. Oh, hold on. You gotta make sure to rename that too. Okay, cool. Let's see with the FFmpeg headers. So it's basically libavcodec, avcodec.h. All right, let's see if that works now. And boom, it actually does work. Lovely. So we can actually right now use, now the real question is, does this include what is it called? Libplacebo, I think. Let's see, downloads, FFmpeg, libplacebo. I wonder if it does. And no, it doesn't include libplacebo, interestingly. So should we like build that ourselves or what? Yeah, I think we should build that ourselves or something. Yeah, we gotta find out how to do this. Or, you know what we could do? We could open right now open code and research using it. It would be able to research much wider on the internet than a simple like search on the browser here. So okay, cool. So let me just, what can I say? I'm just gonna remove this, I guess. Can I? No, I can't. Anyway, let's just start a new session. Fine, whichever. And let's just say research. I'm using Gian FFmpeg libraries. How can I add libplacebo on Windows? Pre-built binaries. Search the internet. Let's see. And while it's at it, oh crap, wait, it already finds something, I guess? Additional libraries in full build. The essential build does not include, I mean, we have actually installed that. What the hell? Let's see. Because that's, I mean, I did the full build. And it doesn't include it. No, it doesn't. Release full. Oh, let me try. I mean, I did full build shared, not full build, but I don't think. Let's see. Fine. Right. Wait a second. Is there lip placebo here? Oh, crap, wait. There is lip placebo, but what? Well, that's strange. Well, let's see if this full build would include lip placebo. Oh crap, 2 hour, what the hell? Masin Moha, welcome to livestream. Hello. What we're using today? We're using C++ and CMake. And we're trying, I've set up like the FFmpeg libraries so far. Myself. Because like the AI really suck at that part. So badly. I try to give it, yeah, CMake. Modern CMake though. Yeah, I'm not sure why this is trying to take like 2 hours, bro. What the hell? I hope he recovers. Yeah, CMake sucks. CMake really sucks, but I got used to it. Because like C++ and CMake is really unavoidable if you want to exploit the ecosystem to its best and like create Vulkan graphics applications and like FFmpeg stuff. Yeah. Alright, I think it's much faster now. Cool. But anyway, let's see again what it says. Extract and verify the placebo. Filter. Wait, is that just the filter? What the hell? The placebo filter? Oh, wait, what? How? So it says that lip placebo is like linked statically, but I still need includes though. I didn't see any includes. Crap. See if there are other ways. There are other ways to to have libplacebo on Windows, binaries on Windows. I have the shared builds here, but libplacebo includes doesn't exist. I mean, hold on. Let me just make sure that this actually, if it contains it or not. Here's the bin. What the hell, bro? This actually doesn't contain anything. It just contains the binaries pretty much only. That's stupid. That's really stupid. All right. Let's just give it this path. And let's see. As MSYS2 packages. Libplacebo. Wait, what? Oh. Bro, it's that simple? Really? Extract? Bro, what the hell does this okay. We got some bin here? But wait, how can I be sure that this is the right FFmpeg that is like compiled in there? Includes. Alright, so those are the includes. Nice. Some shaders. And some utilities. And then we got lib. And they even have a pkg config here, interestingly, and some share licenses. Okay, license. Alright, so that's interesting. Alternative tool chains if needed. Also has MinGUI, Clang64. There are no official standalone release binaries, only source. Well, that's interesting. I didn't knew you could just download the MSYS binaries like that. Would it match my FFmpeg Gyan DLL though? I'm using ClankCL. But wait, wouldn't that be actually like MinGW? Wait, if you're compiling the import lib is what? But must link against the DLL won't work. Yeah, no, I don't think that would work. Bruh. Wait, are GAN builds like MSVC? Or MinGW? The import lib won't work directly. Ships GNU import libraries. Which can't consume reliably options. The import won't work directly. Yeah, hell, I think I'm just gonna probably build it myself. Again, builds are min GW. What? I'm so confused right now. Wait. Let's do a little test just to make sure it at least works. Give me some C++ FFmpeg code just to make sure it's working. Come on. Alright, so let's grab this extern C, or you know what, let's just copy this whole code, pretty much, it's fine. And let's just do this. And let's try to build this. Now let's see what it's gonna say. Would it link successfully? Because okay, it does need like an argument here, so we need to download some testing things. So as you can see, AV version info. Okay, so this actually worked, which is cool. It worked with with Clang CL. Three separate reasons it works, none of which require the DLLs to have been built by MSVC. Uses the same AV. Oh crap! Wait, you can actually use the same. Wait a second. Okay, let's continue. Every compiler uses the same ABI, so any compiler can call it. libplacebo exports plain PL C symbols. So any compiler can call it. The linker is what matters, not the compiler. Bro, what? Well, that's strange, but let's test that theory. I need first of all like some sort of a video file to test on though. And I don't remember what that file is called. Disk debut. Welcome back to livestream. Bunny Blender test video. I don't remember what it's. Oh yeah, Big Buck Bunny. I don't remember where to download this though. I think here or something. Right, there's 2 downloads here, and the new release 4K. What? Just use bad apple. What is bad apple? All right, so let's go with 1080p. I don't know, 60 FPS. Normal. There's even stereo here, interestingly. I'm not sure what's that. Arc and so on. Anyway, let's just go with this one. No, I don't know. Am I missing something? It's also used for testing audio video capabilities. Really? What? I can't find it. Like, how do you research about it? Right, and let's extract all. Good morning, Yo-Yo Man 3D. Welcome back to the live stream. All right, and here is here is a video here. So that's nice. It's the one song everyone replicates everything. It's like Doom anyway. We make it run everywhere. I see. Where can I find it? All right. So we got that, and I don't know where I'm gonna put it. To be honest, let's just say tests maybe. YouTube. Okay, I'll get copy striked if I open up YouTube. There you go. And let's just say Kodochaku video player. And let's give it that BBB sunflower. Or you know what? Just for ease of use or ease of testing, I'm just gonna copy the, or whichever, never mind. I'm just trying to test this first. Copy path. And yeah, it says that the duration is there. And so yeah, it does work. Cool. So we got it set up. We got FFmpeg set up on Windows. Such a miracle by itself. So also about defining the song, you can get copyright for testing your video player with bad app. Yeah. So nah, we're just gonna use the good old I have Alzheimer at this point. Big Buck Bunny, yeah. All right, so CMake list, and now we should also set up lib placebo hopefully, and hope it works. Because if it does, we're not gonna be making our own Vulkan render from scratch. Yeah. So let's see. We got this from the AI. Apparently, you can just like freaking download the MSYS mirror like package just like that, which is insane. I didn't knew you could do that. But you know what? We'll test it. We'll try. And I'm kind of having a deja vu here for whichever reason that it's not gonna work. But I don't know. We'll see. So MSYS mirror. MSY. I've never actually tried MSYS, by the way. Or like packages. Can I like browse the MSYS packages? Okay, I can. Nice. And I could just look for lib placebo apparently, right? Yes, there you go. And but wait, aren't those like dependent on the like the runtime of Segwin and so on, or whichever that is? I'm not sure. That's the base packages. Wait, what? Source files. They can be GCC Clink only. Yeah, we're gonna try that and see. Wait, it did say like UCRT. There you go. UCRT Clink 64. Shouldn't I use like Clink 64 though? Yeah, it's MinGW only. Yeah, I mean, wait. You know what? Let's just try it. Let's see what's up. Let's see what's up. Fine, whichever. Instead of like overthinking here, like what the AI did in the previous stream, which I removed. Let's just try it. This is the best strategy you could ever do in software. Just damn try it and see if it works. That's it. Done. All right. So I got this UCRT here. So I'm just gonna copy this stuff. I'm gonna come here. I'm gonna put that stuff there, and there you go. We got some DLLs there. We got some lib stuff. And yeah. All right. So let me just, I guess tree maybe. UCRT is compatible with Clang and GCC. Yeah, I mean, like FFmpeg kind of probably have the same story, and it seems to worked. I don't know. I think compilers do support it. Yeah. All right. So wait. Let's just grab this, and let's come to the AI really quickly. Here. Now add lib placebo 2. Okay, let's set the placebo there first. FFmpeg there, and well, yeah, let's just do it here maybe or something. Or yeah, I'm not sure. Oh man, I'm like overthinking. Anyways, FFmpeg, let placebo import target, find package threads required by lib placebo, and find package Vulkan. Add library, placebo, find library, names placebo lib placebo in the path, no default path. Set target properties, target include directories, import location. Attach the system dependency directly to placebo in the Vulkan found. Okay, let's try, I guess. Alright, so we got before add executable. We're gonna put this stuff here, and probably it just wants like the Vulkan headers, not the Vulkan library, I think. And let's try to run this. And I guess that's probably works, right? Yeah, it seems to work. Okay, and what if like right now I try to link placebo? Okay, now let's actually test if this works or not. Okay, so I have access to it now. Nice. So now I gotta figure out how to get this to work. Pretty much. I'd love some code to actually trial a placebo now. Let's see. So I tried this code to make sure FFmpeg works, and it works. Extend it with some minimal code that would make sure that our lib placebo setup also works. Alright, cool, let's go. Alright, let's just copy this code because we're just testing right now. We're not really writing the program, just making sure at least our actual like CMake setup is working out just fine. And let's give it the headers that exist in lib placebo really quickly because yeah, let's just do this and say ls. That context.h doesn't exist. Otherwise, if the AI can't really do it, we're gonna look into the ffplay source code and do it ourselves. Moved away from a new release, consolidated login. Initialize via pl log create. Alright, let's just try this now. And I guess maybe that works. Let's see. Well, let's first of all build this. And boom, we got a problem. Because it's not in an import library. Huh. Okay, let me give it the CMake code that we currently have, and let me give it the error. And let's see what's gonna say. All right, back. Okay, let's see what's up. You tell that your links must define PL export static. Add PL export static. All right. So placebo. Where we should do that? In set target properties. Here. And no, it still doesn't work that way. So no, it still doesn't work. I mean, whichever floats your boat, just get this to work first. And no. If I want to keep it purely, set both PL static and PL export static. Okay, let's try this out. All right, let's try to like clean build. Yeah, that doesn't seem to work at all. What? So that's a new error, huh? Yeah, look at that. There you go. Is its own missing Windows API library. Link GCC min GY runtime compatibility libraries in MSVC. Hell no. Hell no. No, no, no. Alright, so what's my options here? I don't think I have that much options, don't I? Let's see. So we got, wait. This is MinGW. Oh, so this whole thing is like like, how about this clinks? It's also MinGW, I think, right? Yeah, they're all Minji. So MSYS is just not a choice, really. Can I just build it myself? I think it uses meson, so I'm not sure. Oh crap, I need Python. I don't think I've installed Python yet. Alright, let's try to get this to build ourselves. Fine, who cares? It's a one-time thing. Okay, so we're gonna install Python and Meson. Come on. Yeah, I've never done this before. But let's see if it works. Otherwise, we could just drop libplacebo and just code raw Vulkan, I think, at that point. But yeah, if we use the libplacebo, it would save us a lot of time and headaches when it comes to Vulkan, because it's just going to give us a lot of things already built in. Add commands directory to your path now. Yes. And yes. No. Okay. Right, so we got Python. Cool. Let's try pip install Meson and Ninja. Okay, because like libplacebo uses Meson. Oh, I could install Ninja for using Python. That's interesting. Well, I'm already using Ninja here. Okay, let's add this to the path. And I'm gonna remove my existing thing, my existing Ninja path too. And let's try this out. Environment variables, path. And let's just remove this, I believe this bin, right? Sorry, this C bin. I'm not sure what the hell is this anyway. And let's just add this guy here. Okay, and let's try this out. Let's first of all see if I have Ninja now. Yes, I do, cool. Meson. Yes, I do. Sick. Clone and build libplacebo with MSVC. Sure, git clone, fine. There's a lot of terminals right here, confusing. Yeah, let's just start a new one, fine. And let's just clone libplacebo. Oh, it's recursive. It's cloning all the third parties. Cool. And now this is the source code of libplacebo. So next we gotta use Meson, I think. And there's Vulkan enabled. Okay. Okay, so let's see what's going on here. Yeah, so it's trying to find atomic, interestingly. Full log can be found here. Okay, text. Wait, open. How do you open? Yeah, there you go. I hate the fact that this is in French. I have no clue how the heck it made it in French. My God, I hate French with a passion. Crap. Anyways, it just detected that I'm in Morocco and it just made it French. My God. All right. So well, that's too big. All right, fine. Let's just only copy this stuff here. Did I just hear Morocco? Yeah, Morocco. Okay, let's go. For atomic, which is a GCC Clang. Pass the atomic disable to Meson setup. Hey, I'm from Morocco. Yeah, I'm from Morocco too. Okay, lever. It's very hard to find like Moroccan people that uses C++, uh, in a like, or like Zig or Rust or Odin or whatever. Anyway, Meson Vulkan enabled. All right, let's go. A known option atomic. Let's go. More of an Odin Zig person. I see. Yeah, like CMake and C++ is a pain in the ass, but like if you want to take advantage of the ecosystem, then you don't have that much of options, you know, most of the time. But yeah, CPP is nice, but man, do I get stressed not being sure that the structure run. Yeah, I hate it too. I hate it. Like all those crappy like implicit stuff, like you gotta need 5 constructors and crap. It just sucks. And you can never know if it like moved the thing or like it copied the thing and it just end up with some weird bugs. Yeah, it just sucks. It just sucks. But you don't have to use that stuff most of the time. You could just like do kind of like program like C but in C++. But yeah. Anyways, what's going on here? So a known option atomic. Huh. Yes, like does Meson support MSVC? That's the real question. Yeah, this is annoying. I've never compiled a library using Meson in Windows. Windows is such a pain in the ass when it comes to the dependencies, but you just gotta go through it for the first time. Is it like in GitHub or what? There you go, last week. Also, you might want to check your domain. Can't access it. Yeah, there's a problem with it. I'll have to fix it. All right, so there is some releases, but well, it's just source code. I'm not sure if they even like support Windows in the first place. I mean, FFplay uses it, so. And oh, they actually do support Direct 3D. Okay. Project website. There's nothing about like CMake here, I think, at least in Windows. So that's very strange. Or you know what? Let me throw let me throw the freaking agent on it. Hold on, hold on, hold on. All right, so yeah, that's real. So I don't have to go through the pain myself. I didn't. You could just. All right, I cloned the lib placebo in here, and you have access to ClankCL, Ninja, CMake, and what else? And Meson and Python to get it to build. Like read its Meson script first. Let's see if the agent would figure it out. Because if I keep using like Gemini there, it would just keep on getting me in circles. Now let me inspect the Vulkan SDK layout and the VS toolchain. Right, hopefully I would get this to work. I just need a damn pre-built library. I wanted to actually do this on Windows just for this, you know, crap, because it's actually very easy to set it up on Linux. Like, just straight up, you could do all sorts of things. You could just add package, or you could even build it from source easily. But Windows, another freaking story. Now let me inspect the Vulkan SDK layout. And since I want to try like also the hardware decoding stuff, yeah, I want to try like the hardware video decoding stuff. I don't want to deal with NVIDIA driver bugs when it comes to Wayland and so on. So yeah, I just gone with Windows because of that. Like, at least for now. But obviously I want to make this cross-platform, so it should work on both systems. But yeah, we'll see. Let's see. What the hell is that? Build type release, Vulkan enable shaders configure. What? How the heck did it? Bruh. Weird. Okay. But yeah, while it's doing its thing, let's just look into something else. Like, for example, how do you install pkg config in Windows? I believe there was a way, pkg conf, I think. The SDK is GSLang, lib is a... But Messons refused it. Bro, that's insane. What? I can't believe it's this crazy in Windows. Like, what? How do they compile FFplay then? I mean, FFplay is using it. Weird. Anyways, so pkg config Windows or pkg conf. That's why I use mingw. Well, mingw gonna have like problems with other bullcrap, like the MSVC libraries and so on. And since you're on Windows, you gotta use like the MSVC ABI, bruh. Otherwise, you're gonna be in trouble with other things, like, you know, for example, the system libraries and so on. But yeah. Build lib placebo with 5.6 megabyte. Import lib. Huh. I guess it worked maybe. Really. Did it? I think it did compile it, which is nice. Yeah, it's making its own smoke test, which is interesting. But yeah, I think it compiled it successfully. I don't know how the hell did it. There was a lot of errors along the way, but it did. Crazy, I guess. Ooh, it's gonna install on my system. All right. Interesting. Honestly, yeah, that's even better. Everything in place. Let me pick the generated, record the exact rebuild steps for you. Bro, wait. Okay, where can I find this though? Like users, lib placebo build, and Win32? Or where's the build? I don't know. But anyways, let's see what it said. Builds is pure C++, no pthread DL, uses vendor Vulkan headers, and gets its Purview compiler from GSL lang or shader C via dependency. No PKG config available, shader C route impossible. Switch to GLSL lang from the Vulkan SDK, no PKG config needed. I see. Fix the link, miss on only linked spur. So like if you want to use with the lib placebo, if you want to use, what is it called? Damn, I forgot it's slang. Yeah, you're kind of out of luck. I mean, unless if maybe like slang could like transpile into GLSL. But yeah, the way that lib placebo is doing it, from what I understood so far, is that they include their like runtime compiler, which kind of sucks because like your player becomes huge. But on the bright side, you could compile like, let's say, video filter, for example, or whichever on the fly when you need them. And also it have a much easier or simpler setup for like writing shader programs, which is quite nice. And you don't have to write like raw Vulkan stuff yourself. At least not most of it, but anyways, fix the link, miss on only linked spurv.lib, so I added the SDK static libs via wait. Fix the link, miss on only linked spurv.lib, so I added the SDK static libs via DC link arcs, CPP link arcs. What? Yeah, this is computers like rocket science. I don't know what it said there. Anyways, compile the smoke test with ClangCL linked libplacebo.lib, ran it, and entry points. Okay. Install the SDK libplacebo dist. Okay, dist here. Boom, and we got the DLL. We got the includes. And we got the damn lib. Nice. Only depends on vulkan1.dll plus system. Wait, depends on vulkan1.dll plus system MSVC runtime DLLs are statically folded in, nothing extra to ship. Sick. But how big it is? What? Oh, there you go. Damn it. 5.48 megabyte. Alright, anyways. Must run inside with ClangCL to rebuild. They need PKG config for their dependency lookups. Caveats. LCMS, Dovi are off. And D3D11. The SDK even ships Pervy Cross C shared lib, so D3D11 would work if you install. All right, let me see. Hold on. Where's the? Oh, bro, what? Wait, where's? Bruh. Oh. It's right here. My God. Okay. Okay. Let's see what's up. So here we got these. Which one is Windows or what's going on? I think there's MC here, x64. So maybe that's that. And this one is ARM. All right, so let's try to download that, I guess. And keep, oh crap. Open file. And yeah, let's go. Boom. So we got pkgconf. But I guess let me just do like restart it. I installed pkgconf. Check it out. All right. I guess I would just like probably upload this to Google Drive or something and then give you guys like a link to download it if you need it. Can I just compress this quickly before it starts to do anything on it? Yes, I guess I did it. Nice, just in case if it does something stupid. All right. Yeah, people that are good with like CMake and like this weird crap like what is it called, SPIR-V and stuff. Not SPIR-V, sorry. I mean PKG config and all these build systems would be really, really in demand, I think. Because even AI kind of sucks on it from time to time. But anyways, now let me update this setup. Though the agent was kind of fine actually in this case. I don't know. Now the nice thing about the agent, it actually have the real context of what the heck is going on. And it could easily make little tests and find out itself what works and what doesn't. So you don't have to go through crazy like blind trial with Gemini, like with a chat bot, which just doesn't work most of the time. Yeah, this is some wild stuff. Yeah, see, there's just a lot of gymnastics going on here. It's insane. And uh-oh, it compacted stuff. That sucks. It's gonna lose a bit of context there. But yeah, I definitely have to like study how it did it exactly, because what the heck. Or maybe we could just ask it once it's done with all this crap. Oh, what? Build complete? Well, we don't want the D3D11 backend to be compiled in though. I mean, Honestly, we could even try the D3D11 backend too. It might be simpler, I don't know, like on Windows. But anyways, whatever. Oh, I guess it's gonna switch the libraries for me. I see. I didn't ask it to, but okay. It didn't use the CMake preset for whatever reason. Okay, so I guess we finally probably like finished the freaking lib placebo setup stuff. I don't know how the heck that even worked. Okay, did it change my code? Yes, yeah, we already have lib placebo stuff here. So if I try to run this with, wait, what the hell? Yeah, I need to give it this path, copy path, and boom. All right, so lib placebo initialized successfully. Sick. Sick, sick, sick. And now we got the ouch. Wait, lib placebo bin, which includes the DLL. This includes and the lib. Nice. All right, so now we're gonna actually start vibe coding. So I'm gonna make a new session in Kodochaku video player. Read the project. And let's go. Let's go, let's go. Initialize the lib placebo, then opens a media file via. Make a video player using lib placebo Vulkan backend. let's see what's gonna do. Whoa, okay. So just like setting up lib placebo on Windows was hell. I don't even know how it did it, actually. I should ask it later on how it did it. But anyways, I'll build a real video player, FFmpeg decode, lib placebo, Vulkan rendering. Win32, what the hell? Bro, stop it. Get some help. What the heck? Win32, really? Hold on, let me check out how we can set up like SDL2. I guess from the Vulkan SDK or whichever. Quite. Bro, what? Required, bro. And yeah. Next step, I'm also gonna add another thing, which is, so we got the Vulkan SDK, huh? Where's the Vulkan SDK? Okay, there's just a lot of folders right here, so confusing. And we got the CMake, and let's just say list append, and we're gonna do it, I guess, well, not here. Yeah, we could do it here, I guess, fine. List append CMake prefix path, I think, to this. Well, actually, instead of the like hard coding it like this, we should use NV. Okay, so wait, does it work like this or what? NV. Oh, like this. Okay, my bad. And then Vulkan SDK, I think, slash CMake. And let's go. And then hopefully I should be able to find library, SDL3, or like SDL, I guess. Wait, find library. Yes, sorry, find package, I think. Yeah, find package, my bad. Find package, SDL3. Or just SDL. Yeah, required. And whoops, we got a problem. Could not find SDL. Why? No, I changed CMake to use the SDL in the Vulkan SDK. But it's not working. Read it. Oh, I think I should say SDL3. My bad, sorry. Hold on. Wait, let me make it use SDL3. My bad. And boom. Right now we got SDL3 done. There you go. And we're just gonna say SDL3, SDL3, and we're good. I added SDL into CMake. Okay, let's go. Well, that was an adventure to get this to work. Building lib placebo, finding the FFmpeg binaries, piecing out together the CMake. This is where most people fail when it comes to creation of video player. SDL3 is bundled with the Vulkan SDK. Oh, well, it's taking some time. Other than that, I'd like to research on Windows Make. The last time I'm off to sleep, Ella. Good night, Messine. Thank you for coming in. So next up, I'd like to try to find how to install Make on Windows, because I did get it to work at some point. I mean, you could use Chocolate, right, or Scoop. Huh, that's interesting, actually. But yeah, last time I tried it, you need like a lot of hoops to go through to actually install it. I hate Chocolate, honestly. I feel like it's too much heavyweight, too much magic. Like, package managers just kind of suck in Windows, really. I also tried Winget and Scoop, and while they do work to some degree, but a lot of times you'd find some problems with them that would bite you when you least expect it. So better off just like installing the thing yourself from the official website and call it a day on Windows, really. But yeah, now dated alternative use was MinGW, but the project seems to be abandoned. So better what? MinGW outdated? Abandoned? What? No, really? That's weird. GNU Win32. What? Make is newest. on Shoko. What? Make version 3 over a year ago. Who's this guy is talking about? Why? What the hell is this guy talking about? An alternative. They also told about that. I don't know. This is taking years. Just set up a window. Oh, they were talking about the old MinGW, not the MinGW 64. I like this guy. He gave like a compilation of the thousands of methods, because that's why I'm actually reading this whole thread here. Because essentially people tell you like all these methods, but they don't tell you like what's version, what's different exactly from the other methods, etc. Empty error messages from SDL. Why the hell that wouldn't work? I don't get it. Wait, wait. Hold on. Stop it. Did we copy the DLLs? I don't think we did. I think that might be the problem here. Or isn't it? Wait, what? Oh. Okay, never mind. Oh, that's strange. Also, you're saying that system libs will not be compatible. You are right, but MinGW ships its own A files like Visual Studio does. Well, yeah, it feels like a hack mostly. I don't know. It's just gonna bite you at some point. I'm pretty sure there is some things that you can't do in MinGW, and like even if you can do, there just requires a lot of hacks and a lot of workarounds. Yeah, it just overall it kind of suck. You know, like if you're on Windows, just use MSVC or use Clang CL, which is MSVC compatible, but used in Clang instead of MSVC. But yeah, that's my take. But compiled version, not sure what the hell is wrong with SDL here. That's unusual. SDL should work just fine. Oh, I think I get it. What the hell it did here? What the? Wait, bro. I see. So it was working with like the old SDL errors? Bruh, I swear, bruh. It's insane. Anyways, I guess let me just set up the SDL stuff myself because it's just gonna go wild again. Now that we actually started and verified that lib placebo FFmpeg is all working, let's actually start the real deal now. And let me clean up my my thing. It's a mess here. We're gonna keep this here. Yeah, we could go back to this issue later. All right. All right, now what we're gonna do next is, well, work on, let's start with the SDL3 main callbacks as always. So let's add the compile flags or whichever, like compile definitions, sorry. Where is it? There you go. Private SDL main use callbacks. And what the heck is this? Okay, next, let's see what we could do here is we should just grab the app init. Right, and let's just remove all this code really. So that's first. Next, we got the app iterate. We got the app event. We got the app quit. And there you go. Next step, you write like a class SDL exception, std runtime error. All right, and then you write SDL exception, std runtime. Well, what we're gonna do here, I think we're just gonna say std runtime error, std format, and yeah, we need like some location. So we're gonna do here std source location, I think. Yeah. Like source location current, I believe. Though obviously you gotta include source location for that to work. I think, I guess. Really? Yeah, so what's up? What the hell? Oh, wait. What C++ version we're using here? What I didn't mention. So maybe that's what's going on here. And we're gonna be using like 23. Standard required on. And set cmake cxx extensions off. Build. Now I guess it would work maybe. No type named expected. And yeah, there you go. Include format now too. And format, we're gonna go with SDL error to this, and then SDL get error. All right, and we're gonna also include the log. As for the log, we're gonna do something like this, like this, like this. And next, we're gonna say log dot file name, log dot line, log dot column, and then log dot function name. And boom. Now, does that work? Yeah, kinda, I guess. All right, and app init, app iterate, app event, and app quit. Look at that. Now, what we're gonna do here is we're gonna have like a struct app, right? We're gonna have none of that bull crap of class or whatever. And we're just gonna say, well, let's see. I'm gonna have like an STL window. And we're just gonna say that the app, well, actually also gotta make sure to say try catch, std exception, e. Is it like E like this or what? I think like this. I'm not sure. Don't remember. I think const, right? And then you just do like std print line, I think. Std error. And then I guess you just say e dot what. You just include print line. And there you go. I think that's maybe it. Yeah, I think so. Try with exceptions disabled. Ah, I see. So I remember there was like if MSVC or like, yeah, how do you check for MSVC like backend or whatever? Sorry, frontend. So how are we gonna do this? Well, let's go to Gemini. How to check for MSVC like frontend. MSVC or Clang CL in CMake. Modern CMake. But whichever. There you go. Oh, simulated ID stir equal. Bro, what? CXX simulated ID. Detect any MSVC like compiler. Ah, okay, so you just do this actually. Okay, fine. So now we could just say, I guess, slash how to enable exceptions. I think it was like EHSC or whichever. Slash EHSC. And oh, you could just do it this way. Yeah, let's just do this. Whoops. Let's come down where we're creating the executable. And let's say if MSVC code Chaco video player EHSC. I guess now that would work. All right, and now we got try working hopefully. And obviously we're gonna return SDL app failure. And here we're just gonna say that the app or auto app is equal to new app. And yeah, and we're gonna return like SDL app, I guess, continue. And we're gonna say that the app state is equal to app. I could let the AI do this, but it constantly do things that I don't like. So I'm just gonna, write the initial code myself. So it kind of picks up on it to some degree. But yeah, SDL app iterate. We're gonna switch or what? No, we don't need anything currently there. So for the SDL app event, you're gonna switch on the event type. And in case of its is SDL event quit, they're just gonna return like SDL app success. That's it. Otherwise, we're gonna return SDL app continue. There you go. And yeah, that's that. Now we're gonna say SDL init. Well, essentially, if not SDL app init. Sorry, not that. SDL init. Yeah, SDL init video. Later on, it's going to be also audio, but for now, I guess we're fine. Or yeah, fine. Let's just add audio because we're going to need it later. And if you forget it, the AI would be confused why the audio doesn't work, and us generally. And yeah, let's just add it. Fine, whichever. So if not, then we're going to basically like throw an SDL exception. And obviously it should be, yeah, I'll just use a struct, who cares, instead of that. It's class bullcrap. Okay, so if not SDL init, then we're good. Next, we're gonna create a window. So we're gonna say app.window is equal to SDL, create window, and then the title would be, I don't know, Kodo Chaco video player. And the width for now, I guess 800, 600. SDL window resizable, and SDL window hidden, and maybe SDL window high DPI or whichever, high pixel density. I think that's it for now. And if not app window, then basically throw an SDL exception. You're good to go. Though you could indeed go ahead and even create yet another function called check or whatever. So it would be like check, and you give it like some, what these guys return, hold on. They return, I think, a Boolean. What? Yeah, Boolean. Okay, so check Boolean result. And then you would just say if not the result, then throw an SDL exception. And yeah, I forgot about the lock though. Oh, it's already going to be taken care of, which is nice. But here, obviously, we gotta need to add them. Add it here too. Just like this. And add it here, lock. And we're gonna do a similar thing for this one, but instead of bool result, you're gonna go with some generic, I think, template type name T. And then you would have like some T results, and if not, or maybe it would just work out just fine with the bool result too, no? I mean, I think so actually. So like you could just say right now, check just like that, and then here same thing, like check app window. Does that work? I mean, I guess so. So that's fine. We don't need any of that crap. Nice. So that's cool. Check app window, and then finally we check on, like, what is it called? SDL show window. App window. And we're good to go. Non-void function. Sure, return SDL app continue. Okay. We could also like create a new file called clang format.clang-format, I think it's called. And let me see. Wait. Give me a clang format file. Okay, based on style LVM, language CPP, standard latest. And let's add this aligns public protect. You know what? I think maybe let's just grab that and just put it there, I guess, maybe. Region. And also I'm just gonna tell it keep it minimal. Keep it minimal. Just LVM and tabs. That's it. Oh my god, let's go. That's what I'm talking about. And now hopefully, yeah, but it doesn't like really respect my tabs. Apparently. Is this like required? Huh, it doesn't respect it. Yeah, I'm not sure why. You know what? Let's just delete this anyways. Whatever. I don't know. Anyway, next. Let's try to actually run this now. And we're getting some problem, isn't it? Wait, try catch. Oh, I did use like a steel main use callbacks or whichever. Oh, did I write like a main function here somewhere or what? What the hell is it talking about? Is that CMake line right? Oh, it's steel main, I forgot. Man. And we got a window, nice. Okay. Another thing I'm also gonna like prepare though is this try catch thing on every single function callback there. So like try here, then catch, and try, catch, and try, catch, and we don't return anything. Okay, so yeah. Read the code. Or you know what? No, stop it. Let's just start a new session already. Read the project. Even better. Let's go. Oh, one little thing though that I actually kind of forgot. Delete app state. Static cast or like reinterpret cast. I don't remember. App probably reinterpret cast, but we'll see. App state. Yeah, that works. Static cast. And let's actually do git init really quickly. And I'm gonna make it git ignore here. So git ignore. Let's ignore build. And well, not build actually. Ouch. I'm not sure where this build came from. And yeah, it still works, right? Yes. So that's cool. All right. So now let's just, can we? I did add out there. What the hell? Git status. Git add. And yeah, and let's just say git commit -m init, and boom. All right, so wire up lib placebo. Okay. Wait, hold on. Hold on. Use FFmpeg to create a Vulkan context. Then use libplacebo and import that context. Let's start small. And actually, wait a second, I forgot one little thing, which doesn't really matter that much. But let's just do it anyways. So we just use like a more modern style. Right, Ocho. Ocho. And yeah, there you go, cool. Ocho. Void. And boom. All right, so that works. All right, continue. I changed the code just a bit though. main.cc cpp, make sure to read it. To read it true. All right. Right. So the way to do it, let's check out ffplay source code. So there's like an ff renderer, I think here, if I remember. Renderer. There you go, ffplay renderer. Okay, where's the implementation? .cpp. So we got av hw device context create. and just say pl Vulkan import. Okay, I'm gonna take a little break while it's at it. Well, the moment I tried to take a break, it just like started actually freaking writing code, which is interesting. It's always in reverse when I try to do something instead of just waiting for it, and then somehow, for whichever reason, it works. It's wild. Really wild. Just magical stuff. And ooh, nice. That's what I wanted. Sick. So what it did here, it added check AV like my kind of style, which is lovely. And then it added this AV buffer ref HWDev PL log, PL Vulkan, and PL GPU. Build vacate dict. Alright, so here it's basically creating an AV dictionary. And wait, allow always. Anyway, so it's basically creating a dictionary here and std string inst. Weird. So it's appending an ext. Where, okay, so this is what append.ext is. All right, so basically the thing is in, okay, let's go. When creating like an FFmpeg context or like an instance, etc., you could specify extra extensions that you want, like this, by creating AV dictionary and creating a string. and then in that string you would add extensions delimited by a plus. So this is exactly what I kind of doing here. Okay. All right, so append ext, and for every one of these we append the ext, and here we just got like the instance extensions probably from SDL, and then we set the avdict set, right? So we set the key instance extensions. So basically this dictionary would include all sorts of entries that you would give as options to the creating like the Vulkan device and instance, etc., using FFmpeg instead of creating it ourselves, which is lovely. It saves a lot of time on us, because otherwise you would have to create it yourself, first of all, and second of all you have to like figure out what FFmpeg extensions it needs, and every time you upgrade FFmpeg or whichever, you gotta figure that out again. But yeah, Erzwold, welcome to livestream. Hello, hello. So instead of doing all that bull crap, we're just like adding the extensions we want through the AV dictionary here, which is cool. And then we just let FFmpeg create the Vulkan instance and device and all that cool stuff, and then we just import it in libplacebo for the rendering part and so on. And libplacebo would also take care for us on the swap chain part, which it sucks, and even like the pipeline stuff too, the pipeline part, and all sorts of cool stuff too, which is lovely. All right, so here we just grab all the instance extensions and we build a vibecode. Yeah, so that the function that we have looked into, and then we call AV hardware device context create. We give it the app hardware device type Vulkan device null ptr, and the OPTs we give it the dictionary, and then we free that dictionary. And then we grab the device and the hardware context out of that. We reinterpret cast, as you can see, app hardware device data and device hardware context. Sick. And then we check if hardware get proc address, hardware context get proc address not equal to reinterpret cast. PFN. Oh, warning. If FFmpeg and SDL is different, vacate against this proc. Service creation may fail later. Ah, I see what it's doing. I wonder if like FFmpeg actually provides a way to like... So basically it's making sure that FFmpeg and SDL loads the same Vulkan library. And that's what it's trying to make sure. But honestly, I would tell it to check if there is a way to give FFmpeg our own SDL library thing, but well, anyway, so that's kind of works anyways. So we got log params, pl log simple, std error, log info, pl log create. So we created like a libplacebo logger here, and then here we import Vulkan device and instance, etc., and physical device or whatever from FFmpeg, from the one we used FFmpeg, right? Okay, device features, blah, blah, blah. And here we find the queue families we need, and then we call pl Vulkan import. And then here we create a window, we create Vulkan, and then we show window. All right, cool. Done FFmpeg, imports it, found the ffplay. Okay, now set up the swap chain. The PL swap chain, obviously. Okay, so we have already created the Vulkan context right now. uh, yeah, it was that simple because we're piggy. You know, it's like we're just kind of like relying on FFmpeg for that part instead of doing it ourselves, essentially. I forgot the term. Because like if you check out, wait, here you go, I think. Look at that. So it includes some queue flags, some queue families, the lock queue and unlock queue, which is actually deprecated now. Now item swap chain setup is deal surface resize 2 plus resize. There you go, sick. As you can see, instead of that swap chain images and so on, how long did it take you to understand all this? Like, did you go to college or are you self-taught? Yeah, pretty much self-taught, though I currently study in college too, though an online college. But yeah. But pretty much just self-taught and a little bit of AI here and there. And obviously tutorials, although there's not much tutorials about this stuff because it's so exotic, so new and exotic. Right, so yeah. And also like reading other people's code, reading examples like in GitHub, having experience with multiple languages, seeing how each language do the same thing differently. And like you learn one thing from this project and one thing from that project, one thing from this language and one thing from that language, and so on. Yeah, pretty much. All right, so here it basically, I see that's cool. Now exotic, exotic. Yeah, understand how's the project, how this project going on so far. Okay, so for this project, I've never done it to some degree before, but it was very interesting. So the first problem you're gonna find with this kind of project is trying to get libplacebo and FFmpeg working on Windows. It's pretty easy on Linux. You just say sudo pacman-s FFmpeg and libplacebo and you're good to go. Boom, done. And in CMake you just say find package. But on Windows, on the other hand, you have like a choice. You either try to figure out how you can build it yourself, or you like install FFmpeg pre-built binaries that you just link to in CMake. And we did just that pretty much. We have gone to what is Gyan builds right here, right? And we just like downloaded the DLLs and all the stuff we need for FFmpeg. All right, so this kind of like part of the problem is solved. Cool. But now how about libplacebo? Well, libplacebo where the real problem begun, right? And what I did to fix that, I tried multiple things, but then at the end of the day, what worked for me, I just cloned libplacebo, and then I told the agent to figure it out. It kind of kept on iterating. I just installed like Python and Meson for it, because Meson is like what libplacebo is using. And what the heck this is talking about? Wait, swap chain is created and working, libplacebo imported and picked. Especially doing C++ on Windows the hard way like that. Something like MSYS2 is the Windows way to do what you're talking about. It has Pacman bash. Yeah, I get it. I get it what you're talking about, and I like that way. It's way easier, but you need to use MinGY instead of MSVC, which I don't want to do. MinGY and like I think MSY. Oh, actually no, it doesn't need a runtime. But yeah, like MinGY just sucks, really. I don't like it personally. So yeah, I'm indeed doing it the hard way. And yeah, so after the agent figured, honestly, I don't know even how it did it, how it worked. But yeah, it got us a build that we could work with for MSVC, like that we compiled ourselves, that the agent compiled, and then we just worked with that. So why I use lib placebo? Because it would give us a lot of the stuff that we're gonna need already. Instead of creating a Vulkan render from scratch, it would give us a lot of cool stuff. You can use Minji or Clang, but I hear you. This is way more complex than I was doing to your age. Yeah. So yeah, you could use Clang, but Clang Minji W, not the MSVC ABI, which you're gonna have problems with using other MSVC ecosystem. Like, I don't know if you wanted to use DirectX later on or some pre-built binary that is MSVC, then you're gonna have problems. But yeah. All right, so what's going on here? Lib PL uses strict, so only pair. Yeah, I need specific flavors of lib. Yeah, it's such a headache, honestly. So there's just a lot of ways to go about it, but I'm glad that at least my way kind of worked, and the agent kind of gave us a working build. So that's lovely. We gotta figure out how to make that obviously like reproducible later. But yeah, we'll figure that stuff out later. Anyway, so swap chain works. Let me clean up swap chain setup. What was added? Yeah, C++ headache is why I started writing more C# these days. Yeah, I even thought of like using JavaScript, vanilla JavaScript, and like browser APIs at some points because of it. But you know, honestly, at this point with the agents writing code and like figuring this stuff out, and I already kind of figured out a lot of the CMake bullcrap and so on. Yeah, I kind of got something working. And I wanted to use vanilla JavaScript because I figured out how much stuff, how much bullcrap that the browser actually capable of handling for you, that I wasn't aware of until I tried to make my own stuff natively. It was just a lot of headaches, so I figured out I would just go with vanilla JS in the browser, and then like if you want video decoding, you would just go with web codecs web API. If you want like networking video stuff, then you would just use their WebRTC API. If you want like graphics, low-level graphics, you just go with WebGPU API now. If you wanted, what else? There's even like a WebNN for like AI inference API that is coming in too. But yeah, there's just, if you want like, let's say a virtual file system, then you could use OPFS. Yeah, there's just a lot of cool APIs, so you could do a lot of things easily without like, you know, fighting with the system native stuff and cross-platform stuff. It's just a lot of, yeah. Anyways, so create swap chain creates the vk surface from the SDL window against, then PL create swap chain FFO vsync, synchronizes it to the window pixel size. App now holds and swap chain SDL app event. Clean up, verified that runtime, imported the RTX and swap chain picked, Unom pack 32, and a live window resize completed without errors. Okay, let's see what's going on here now, what it actually kind of made. And boom, we're getting like debug information from, what is it called? From libplacebo. Cool, and we got this working on Windows, which is a miracle. Okay, requested image count for minimum 2. And libplacebo actually give us way more debugging information too, which is lovely, as you can see here. What language gives you the least amount of headaches to program in? Sorry if this is a bit random. Okay, well, depends on what kind of thing do you want to program though. Is it like, are you talking only about native languages or all languages in general, or what? If it comes to C and C like C++ kind of languages, I would say what is it called? Wait. Odin. Odin pretty much gave me the least headaches, but I didn't test how Odin works when it comes to things that it doesn't include in its standard library, right? So for example, FFmpeg and Le Placebo, I have no clue what kind of thing you would do with Odin to get it to work. As far as my knowledge goes, it doesn't have a build system. So like if you want a library, you just like git clone that library and you're done, I think. Yeah, I'm not sure how you, but I really like the way that like most libraries that you're gonna need most, like SDL, for example, GFW, Raylib, and so on, it's already included in standard library. So you just make your Odin file and then you just say import vendor SDL and it just works. At least in Linux, I'm not sure if it have the same kind of way in Windows. I actually have never tried Odin on Windows, but I would expect the same. But yeah, as I said, I'm not sure how Odin works when it comes to things that it doesn't include, like FFmpeg. So that could be the one that would suck, but I'm not sure. Also, Kotlin. If you're not talking about native languages, I love Kotlin too. It's a pretty cool language. As for if I had to start over programming tomorrow, if I had to start right over, I would probably just go with like vanilla HTML and CSS and JavaScript for real. And it's such a controversial opinion, but like going through the headaches of like cross-platform and manual memory management and like cross-platform headaches essentially, and like CMake and multiple languages like Rust and all these languages, it's just like, bro, it's insane. It's like the browser is such a magnificent piece of technology that we have today. Is just crazy, right? It just simplifies a lot of things for you. Any language that needs to be compiled is always an extra layer of complexity for beginners. Yeah, I really like, if someone is just starting out, please don't go into late native like compiled languages. Like, it's just insane. I would just like recommend just mastering. Even if we have AI, go ahead and master HTML, CSS, JavaScript, vanilla. No React, none of that bullcrap. No TypeScript, just JavaScript, vanilla JavaScript, and just get the best at it. And then later on, when you master that stuff by yourself, you could then use AI and then vibe code however you want. Doesn't matter. Because like if you just try to vibe code JavaScript or any other language, like programming in general, you're just gonna suck. It's just gonna give you some very ugly code. And if something goes wrong, you don't know how the hell to work with it, right? Like, for example, if you try this on CMake, for example, oh my god, you're gonna have a lot of trouble. I think, and actually this is kind of lies to some degree, like once you master, for example, CMake here in C++, is that most people that, let's say, uses AI to vibe code, they can't do this, bro. There's no way. This is kind of like, you know, a gatekeeper to some degree, like the complexity of CMake. You can't do it using just vibe coding. But yeah, so that's kind of like an advantage and disadvantage at the same time. But anyways, let's just continue what we were doing here. All right, so GLSL version. All right, sick. Device extension not found. So as you can see, it's initializing Le Placebo, imported the Vulkan device, and initialize the memory heaps, etc. Fortunately, it doesn't use VMA, it uses its own memory allocator, but anyways, whichever. Alright, so what it added, hold on, let me see the git diff here. What? Did it committed that stuff or what? I think it probably committed, no? No. What? I'm so confused. Hold on. Git diff. What? Why git diff doesn't work? Oh. Wait, really? Why this is not a git repo? Wild. Wait. Let me grab and explore to see what the heck have happened here. Something strange. So we have hidden items and there's no .git. Where the hell did it go? How did it got removed? Okay, what if I say git init? Fine, who cares? And oh, what? Default? Where is this is coming from? I'm very confused. So apparently it's probably inside of ouch for whichever reason. Which is strange. Hold on, dev, go to Chaco video player, ouch. Let's just remove ouch for a second here and rebuild this stuff just to make sure. Okay, and let's just say, sorry, init. Yeah, that sucks. Not sure why it's super slow. Anyways, so what it did, so we got here swap chain, right? So swap chain, and where did it add the code for swap chain? Let's see. Create swap chain. So it grabs the hardware device and the hardware context from the here, and then it uses SDL Vulkan create surface. And let's actually try to run this right now to rebuild that stuff. So we can get some, okay, cool. What the hell? Ooh, I think we got like some sort of, yeah, but I guess it's only problematic when it exits, right? Yeah, I think so. All right, so I think we got like some sort of heap crash or whichever. What is it called exactly? When it quits. Debug assertion failed. CRT is valid, heap pointer. Anyways, create surface. We use check here. We got params of the swap chain. You set the present mode here, and then you call pl Vulkan create surface. And why my LSP is not restart language server? Does it work now? Yes, I think. There you go. Boom. So create swap chain creates a new Vulkan swap chain based on the existing vacate surface. Using this function requires that the Vulkan device was created with the vkhr swap chain extension. The easiest way of accomplishing this is to set the Vulkan param surface explicitly at creation time. SDL get window size in pixels. Nice. And then swap chain resize. App swap chain width and height. So this update query the swap change size. This function performs both roles. It tries setting the swap change size to the values requested by the user and turns in the same variables that width and height the swap chain was actually set to, which may be substantially different from the values requested by the user. A value of 0 means a known none, in which case let placebo won't try updating the size. It will simply return the current state of the swap chain. It's also possible for a lib placebo to return its values of 0, such as in the case that the swap chain doesn't exist yet. Ah, I see. All right, cool. And here we got create swap chain after creating the Vulkan context, etc. And that works. Next, what we do. When the window pixel size changes, we grab the new pixel like window size, etc. I mean, you don't even have to do this. You could just use like the event data to grab the new size. But anyways. Bro, what the hell? Just lunged multiple times. Interesting. It did it 6 times or what? Yeah, I think 6 times. Okay, PL swap chain resize, and that's it. That's how you create using lib placebo, Vulkan context, Vulkan swap chain, all that stuff. You do it in 300 lines. If you did it like using Vulkan raw, you're gonna need like, I don't know, like at least 400 lines of code, 500, 600. And it would be very complex than this. But anyways. No, it crashed every single time. Alright, so I think next step we could move on to actual rendering. Anyway, now try actual rendering using now try decoding and or like now try rendering a video. That's it. Right, so I'm gonna take a little break. What the hell happened, bro? There, bro. I'm gonna start a new session actually. Read the project, please. It's just gone off the rails. Oh, crap. So I'm just gonna tell it to read the project and then implement rendering. Inside test, demux it, decode it, and then render it. All right, gonna be back. Okay, we're back. So it actually worked. It actually worked. Boom. Look at that. I'm not sure if it's using hardware decode or what. But that's very interesting. Sorry. But yeah, I really wonder what it's using. Hold on. We have some Vulkan errors, but I guess they're just false positives, possibly. Oh man, wait, hold on. I'm gonna disable the validation layer. And let's rerun this. Let's see if it's gonna tell me if it's used. Sorry. Is it like called hardware decode or what? It should be login somewhere. Hardware acceleration, yes. In fact, I could check out my task manager. And what did I call this? I guess go to check a video player or something? Yes. And look at that. 0.4% CPU. So it's probably, there you go, GPU. But if I check my GPU here and look at that, video decode 60%. Let's go. And even video, oh, but that's my OBS. Crap. I see. So as you can see, the video decode is working hardware accelerated right now using Vulkan. So it's using the Vulkan video decode extension right now. That's insane. And look at that freaking CPU, bro. 0.4%. What the hell? Look at that. That's crazy. I wonder if it's actually zero copy though. I'm not sure if it's zero copy. And this session is probably already botched on this session compaction for whichever reason. But anyway, let's just start a new session, read the project. And yeah, we gotta add audio, obviously, but not now. Hold on a second. I'll just verify the actual code that we got currently first. Single translation unit. So I think it basically took that implementation libav, which contains some syntax that doesn't work on C++, and they put it basically in a C file instead and compiled that one instead. But yeah, so that's an interesting workaround. Sorry, link FFmpeg, the placebo. Oh, I can space toggle to pause. Okay, I could already pause. Nice. Okay. Is it 0 copy? I'm not sure if it's 0. So it is hardware acceleration, but if it is 0 copy, no clue. And I mean, even if there's a copy though, there's probably a very small copy. I mean, sorry, not small copy, but like, you know, GPU to GPU copy. And it generates the shader. Oh, I think it already got the LUT lot. I mean, yeah, it seems to be recompiling maybe the shader or something. But yeah. For ownership key family transfer and render samples those textures into the swap chain back buffer, a GPU side filter copy, which is unavoidable. Oh yeah, obviously you do need that part for the scale and color space, but still, yeah. Is CPU 0 copy? The only copies are GPU resident. Caveats: the software fallback path, non-Vulkan capable codec decodes into RAM, uploads, that's a real copy. And currently there's no frame cache reuse, so each next frame allocates and frees frames per iteration. I see. Though that's heap churn, not a data copy. Alright, so what we're gonna work on next, I don't think I have added audio yet, right? It didn't, no? Or did it? Because hold on, I need to grab my headphones. Ah, it's already connected. Huh? And obviously there's no audio. Cool. Alright, so audio is not implemented yet, right? Implement audio, fine. Let's go ahead. Obviously using the new audio stream. And actually, wait, hold on. Before I do that, let me give it again that reference code from FFmpeg FFplay. Alright, so it pretty much made a player class. Vulkan hardware config. Throw AV, throw SCD runtime error. And player close, AV packet free context, close input. Vulkan hardware config. vcode get hardware config index I++, and it's an infinite loop. And if config on null ptr, then break. Otherwise, if the config methods contains hwconfig method hardware device context, and the device type is Vulkan, then return true. And then we got open codec. Vcodec alloc context 3 codec. So we open the codec here. Well, we allocate it here actually, and then we copy the parameters from the video stream to the codec context. And then if hardware device not equal to null pg, sorry, we got here AV buffer ref. Okay, so hardware acceleration flags. Allow profile mismatch and ignore level. Not sure what is this. Let's oh, it's already using multiple threads. Nice. Nice. Else. Well, actually this is for the software, obviously. When it uses software fallback, I think it does that. Use multiple threads to decode the video. But anyways, so AV format open input, FMT path, null PTR, AV format find stream info, AV format, AV find best stream, nice. AV codec find decoder. Okay. And if you couldn't find a decoder, then the errors, ouch. I hate those like if staircases. I'm gonna tell it to remove them soon, like making a function like check, but for FFmpeg and so on. But anyways, AV packet alloc, so we allocate a packet, then we open here the actual decoder. Wait, there's a lot going on here. Oh. Next frame, if EF then return null PTR, I see. AV frame alloc. And like a while loop here, AV codec receive frame. Cool. So we receive a frame from the decoder. And if it's again, then we read a new frame. AV codec send the packet. So we send the packet to the decoder. Actually here it's just a flush. Okay. So if we're not interested into this particular packet stream, then we just ignore that packet, we unref it. Then otherwise we send that packet to the decoder if we're interested in it. So basically you have like audio stream, video stream, subtitle stream, you name it. And right now it seems to be adding audio right now. Cool. You got AV seek frame, AV codec flush buffers. I wonder if it's gonna use like the SDL one, the new SDL stream, or is it gonna try to use like the old callback based one? Oh, wait, why it's trying to use, I think maybe for resampling, I see. Well, probably it still could do the resampling though. So probably no need for that, I guess. But we'll see. Not sure. Open the audio codec. So I'm not sure, where's the actual SDL audio code? I guess you haven't added it yet? Yes. There you go, cool. SDL audio stream, nice. Use the new method, nice. Okay. Yeah, for real, like the biggest challenge when it comes to vibe coding a video player is just like the CMake setup and like the build setup. Once you get through that, you're kinda done to some degree. I'm not sure if it will get it to work from the first try. I mean, there's no errors, compile errors, which is interesting. Oh crap. What the hell is that? Hopefully it wouldn't botch my stream. Let me hear it again myself. Bro, what the hell? It kind of works, but it's so laggy after adding the audio. And it's getting these errors. Not sure what's the issue. So as you can see, we add code to find the audio stream. in the video file. And then we open the audio codec. Sample rate. Channels, codec name, time base. Layout and init. All right. Next audio frame. And let me just, oh, it's already disabled. Interesting, okay. So next audio frame, and we got AV codec receive frame, read frame, same thing pretty much. But hold on. Oh crap, wait a second, wait. Aren't you supposed to have the same loop? Oh wait, the same receive frame loop, then just fork depending on if it is audio or video frame. Because, I mean, how the hell does it know if it's an audio frame or a video frame then, in this case? Because it's trying to receive a frame here. What? So it's probably skipping frames. Yeah, I think what's happening here is probably skipping frames. I'm not even... Wait. Where's the next video frame, in fact? So here we got like some feed audio. Yeah, what the hell, bro? Yeah, I think that might be the issue here. It seems to be, yeah. Let's see if you can fix this issue. All right, let's see. Hell, nah. Still lagging. Don't know what's going on. Nah, still same issue. You know what? decode, I guess, audio in its own thread or something. I don't know, man. Instrument. You know what? Just remove synchronization, I think. Currently, it's already trying to implement the audio is the master clock. Yeah, it have like those SDL delays. So that could be definitely be the culprit because synchronization is so complicated to get right. I did ask it to add that kind of synchronization, especially that the audio is the master clock here. What the heck? Yeah, that's strange. So I think I'll just probably just discard all the audio changes and start over again, pretty much. It did too much too soon. I forgot to tell it to don't implement freaking synchronization, just like implement the easiest, simplest thing, I guess. And also that dispatch per packet instead of like, yeah. So there's just a lot of issues with these kind of implementation, right? So yeah, we'll just discard all the changes pretty much and just redo that. Though I'm not sure if I have enough tokens for that part, honestly. You know what? I guess I'll just try it. Read the project. I mean, we could just implement it ourselves, at least the simple one. Honestly, yeah. But let's just give it another try. Let's just give it another try. So let's see. Read the project, and we're gonna tell it to read this. Or actually, is it really? We don't need the renderer now since we're gonna be implementing audio. I don't think the renderer have audio. Yeah. Never mind. All right. So let's actually give it FF play now instead. That's what it's gonna need next. ffplay.c. And let's give it that. Read this. And in fact, do we have currently any kind of synchronization, by the way? I think we probably do. Yes, there's a PTS here, and there's an SDL delay. Though I wonder how fast this would be without synchronization, too. So I guess no SDL delay. But nah, that wouldn't work that easy, I guess. Refresh loop wait on event. Can you add a way to disable sync so I can see how fast is the video decoder? It should also remove the vsync. It should make it mailbox. Whoops. Yeah, we should just switch this to mailbox. Let's see. This is on, this is off. So currently it's getting like around 75 FPS in my, but well, this is FIFO though, still. Let me try mailbox. Whoops, sorry. Let's actually rebuild that. Oh, look at that. Now I'm getting actually 150 FPS. And it's probably maxing out my video decode, right? Not really. I'm not sure why it's not maxing out. It's using just 40%. But obviously I don't have like a crazy card for the decode to be really fast. But yeah. So that's pretty cool. And obviously our CPU is just like off. Doesn't do anything. Where is my, there you go. Oh, actually, no, it does. Well, because, wait, interesting. %. So we're probably spending a lot of time on synchronization of the CPU. Maybe that's why. But that's an interesting thing. Anyways, alright, so when off or whatever in that mode. Yeah, honestly, how much time I've been streaming? 3 hours, it's almost 4 hours. Yeah, I think I feel like I'm just gonna let the audio part to the next stream. So I could also research a bit on how best we could do this. Like how to proceed and like try to fix that crash at the exit and and just read the code too. But yeah. Yeah, pretty much I think we're good to go. So we could keep the stream a bit, not very long. It's already too long. Now update the init column, move render creation there. Nah, this toggle is probably making the code very complicated. But yeah, I'm just curious. Okay, let's check it out. And when you click on the nice. Perfect. Alright, so yeah, I think that was it guys for this stream. Thank you all for watching and see you in the next one. Goodbye everyone.